Hey, this is Steven from LegitTechTutorials, and welcome back to my product development series. We're back working on the Tripteron 3D printer build. So with this video, I'm actually doing voiceover after the fact because the video was capturing audio off the wrong mic. Instead of off my Blue Yeti mic, it was capturing it off of my headset, which was over behind my computer, so you weren't able to hear it. So I am recapturing the audio for it so I could just substitute the audio in. So this has been holding up the series for the Tripteron build, because actually right now I'm on video like number 11 or something. 11 or 12, and then this is number 2. So I'm going to try to keep up to date with these so I could have you guys know what's happening, so I can remember what's happening. So basically in this video what I do is I model the STLs. So when I import the STLs to Fusion, I realize that you can't actually manipulate the STLs. So you actually have to draw a parametric body over top of the STLs. And I think here I'm talking about how me and my team have decided that we're going to go with plastic 3D printed arms instead of the aluminum arms with the caps. Reason being is that after watching some of those live streams, I realized that the aluminum extrusion is way too heavy, and what happens is when it's moving too fast, it starts to oscillate as it hits the end of the end of travel. So when those corner arms get really low angles, and when you throw the arm back and forth, you'll have this little bit of an oscillation because of the weight of the machine itself and the mass of moving it around, and then having it stop on a dime at one spot under high acceleration. So the idea is to drop the weight by making the entire arms 3D printed. And also another thing is that the arms that we're going to use are considerably longer than the arms that he's using. Because if you go onto if you will see the bill of materials, he's using 175 millimeter arms, while we're using 11-inch arms, which are like 300 millimeters or something like that. So we're using almost twice the size of arms. So here is where I'm talking about that I want to make a printer sort of like that I just showed you, where it's fully 3D printed, and get rid of a lot of the parts and make it lighter. So in doing that, basically what we need to do is we need to take the STLs and then draw over top of them, and then extrude them out. And then here I'm talking about the print bed size and what we have to work with. So later on, I can't remember if it's in this video or the next one, but we do some calculations to figure out how big of arms we could actually do. And with those arms, we basically extrude out of the STLs that we're going to create to get the full length that we were looking for. And also there are a few STLs in here that we don't need to modify. Some stuff like the shoulders, the effector, and so the shoulders are the ones that attach to the rails at the bottom, and the effector, the piece that attaches in the middle, we could actually use unmodified. So we're good there. But I end up modifying it in order to do the whole model by itself. Another thing that I'm probably also mentioning here is how we are modifying the look. So you'll see in a later video, I actually, me and my team came up with the idea of getting rid of a lot of the extrusion and limiting it down to using actually 4 pieces of extrusion instead of the 9 there. So also what we did is we modified where the X, Y, and Z layout are so that we could have a definite front end of the printer. So a place that's actually that actually looks like the front and gives you full access to get the part off. So I actually did a sketch. Of that modified body, and I believe I show it in this video or the next video. So we'll see that in a second. What else? Oh yeah, also another thing, when we get into Fusion here in this video, basically there is a specific way that we are going to be importing the STLs. So what I learned is that I actually I did this whole video a first time, and then I had to do it a second time, because basically what happened is you can't just import the STLs and then start modeling on top of them. Because what happened, oh sorry, that's my cat. Because basically what happens is the extrusion, the size gets all messed up. So what happens is everything that's in there turns into be like 10 times the size. So there's actually a specific way that you have to import it, and I'll show you when we get into the video. I'll show you guys the comparison of what actually is supposed to be happening, and you'll clearly be able to tell that the sizes are off when I do a few measuring pieces on there. But you can see from that image, the higher Z image there, that's kind of the printer style that I'm looking for. And I believe here I'm talking about, I don't know why he has the trusses there and why that's not solid on the top. But that might be just for him to check infill and actually do a finite analysis on the forces, which I do on the Tripteron after I fully build it. I do the force analysis on the machine itself. But that is kind of the machine that we're building there. 3D printed arms, everything 3D printed except for the rails. Right. So that is what we have set out to achieve. Also, I would highly suggest that you go onto the Thingiverse page, just search Tripteron Thingiverse, and then go onto this page and check out those live streams. Give you an idea of how the thing works if you're unfamiliar. So go ahead and do that if you want to learn more about the Tripteron, what it looks like when it's moving, and stuff like that. So now all we're doing is just waiting until I get into pull up Fusion, and then we'll talk about what I do to import it in Fusion. Because right here I can't exactly remember what I'm talking about, but it's basically what I just went over, pretty much. And I think when I first go into Fusion, I go over that 3-axis sketch, the modified layout that we're going to be using, and then I go into, at the very end of the video, I go into copying the STL by turning it into a model. I basically draw a model over the top of the STL, because the STL you cannot manipulate. You cannot you cannot do any joints on it either. And yeah, so it's basically useless unless you just want to print it, because you can't do anything with it in Fusion. And you could try to do the funny thing is it'll let you try to convert it, but then it says that hey, these are actually triangles instead of N-shaped polygons. But of course they're triangles because STLs use triangular meshes because they're easier to calculate with Pythagorean theorem. So of course they're triangles, right? Because that's what STLs are made out of, triangles. So I don't know what it's expecting it to be. I guess polygons. So I guess it just can't do I guess it just can't do STLs then. Okay, here we go. So now we're into Fusion, and here I show you guys the frame sketch. So there is the new layout of the Tripteron that we're going to be doing, and basically we move the axes around. So now that where that diagonal is across that I'm just showing right now, where that diagonal is, that's a cross support that supports the Y and Z and the X-axis. It keeps them all square to each other so that we have them all orthogonal. And also those dotted lines, the dotted lines that finish the square, that would be the print bed. And the diagonals that meet in the center, that's an idea of where the arms would meet in the center. So you see from here, you go from like 9 pieces of extrusion down to 3 pieces plus the horizontal piece of extrusion. Now you have kind of a clear front, and also there's no collision issues or anything like that with this style of design. So this style of design is good to go. So this is the style of design that we're going to go with, and the layout that we're going to later build design the entire thing virtually, and build the printer with that design. And also this comes with the parts that I have. So each of these axes are going to be 19 inches in length, or a little bit above, maybe like 21 inches in length, because the rails that I have are 500mm rails. So the Y, and I don't want to cut those rails, so the Y, the Z, and the X are all going to be at least 500mm long, because my rails are 500mm. The extrusion will obviously have to be a little bigger in order to put limit switches on it and stuff like that. So here I'm talking about what I did is I downloaded all the STLs, even though some of them I'm going to use, others of them I'm not going to use. And just go in there, download I'm showing you all the files here. And I think I do the tongue, I can't remember. But so yeah, here are all of the pieces imported into a Tripteron folder, and there I have the one that I modeled in the first video, that I'll show you is way off as far as size. I'll show you guys also how to import it correctly so the size is not incorrect. So there I'm showing you guys how to upload. So I just hit upload and I drag the folder. So I just dragged the entire folder into there and then uploaded it. And then here I'm showing you guys how I know it's off by quite a bit. So this cross section here is supposed to be 20 millimeters, right? Because the extrusion is supposed to fit in there. And the extrusion is 20 millimeters by 20 millimeters, but yet you see that it's 240 millimeters. So it was clearly, and here I'm showing you that you can't, that these don't count as faces. You can't reference off of them for the most part. You can't do anything with the STLs. And then later I try to joint off of them, and you can't joint off of them either. So, and then also I tried to convert it, and it doesn't do anything. And it says, hey, they're triangles, not polygons, which again, the Tripterons are, the STLs are polygons. So, and here I'm showing you the actual, I think that was the one I imported correctly. And there you see that the one that I modeled after it, that I modeled off of the incorrect import. I modeled, I didn't even notice, and now it was like 200. Now it was like 200 millimeters. It was 20 inches, almost 20 inches across, which is way too big. It's supposed to be 30 millimeters across. And here I'm just, for fun, just looking at the weight. And so here is the correct, here's the correct one that I imported correctly, and I'll show you guys by measuring as close as I can across. And there you see it's 30 millimeters, 29.49. 459. So that's the correct size. And then here also I do a quick draw to show you guys that it is 20 millimeters on the inside. Twenty and a little bit because I went a little sideways. So that is the correct way of doing it. So what you do is you hit insert, and then you hit insert mesh. And when you hit insert mesh, it will allow you to insert what you need to in order to bring. And right here I'm losing. I can't remember where it is because it moved. Insert mesh used to be the second one. And then here, don't do this. Don't do what I just did. Just ignore that. Basically what I told it to do is ignore the ignore history. But in this, you can't do parametric design if you ignore history. So do not do that. Do not ignore history. And you see here, you just import it, and then you select unit type to millimeters, and then now everything is good to go. The sizes are correct instead of being super incorrect. And this is one of the clamp parts. This is what holds down the what is it called, the belt onto the gantries. But that's one that we don't need a model because it's already modeled, and we're just going to print those. And here is the correct one that I brought in using that specific method of insert mesh. So I'd highly suggest that you do that you hit insert mesh, because it's going to import your STLs really bad. And so here I'm showing you guys what happens when you don't have your history intact. Basically, it's uneditable. You can't go back and re-edit stuff, which is not good. So do not do that. Make sure that you have your history. Make sure that it is capturing your history and that you keep it, so that you could go back and change stuff. But you'll see one issue here right off the bat as I start to model, is that the what is it called? It's not flat on the, when you import it, it's not flat on the ground plane. So you just have to move the STL up a little bit. So basically what I'm doing here is I'm doing as close as possible by eye modeling. While actually in real life later on this causes a problem. But because everything is captured in the history, I could go back and change everything to make sure it works right. So basically what I do here is I just model it according to the outside geometry as close as possible. And you see there, it doesn't, what it's doing is it's just snapping to the grid. Luckily when APSU modeled it, he modeled it pretty with some pretty standardized whole number millimeter numbers. So it wants to, when it snaps to the grid, it snaps pretty close. And basically what I do is I create a few lines. This is where it causes some problems. Don't do what I just did there, coming off the center. Draw it from the edges inwards, because, and then there you see I completely mess it up because it's not flat. And I try to make it flat, but it doesn't work out. So basically make sure it's flat the first time. You see that everyone's now also off. But it's just as close as possible, but you definitely want that to be flat, because if it's not flat, you're gonna have problems. So make sure that that's flat, and also don't do what I'm doing, starting from the middle. It causes problems. Start from the edges and go in. And so basically what I'm doing here is I just draw some simple shapes and some 3-point curves, as you saw, just to get it to get as close to the outside geometry as possible. And then once you get that outside geometry, extrude it up, and then do the tongue. Just mess with the tongue of, then model the tongue of the tongue bracket here. Alright, so here you see that we have it ready to go, and then this is where I noticed that it's not at the it's a little bit off of the ground plane. So it should be 30 millimeters square for that box. So you need to move it up and into the ground plane. Otherwise, it's going to be very difficult to do the it's going to be very difficult to do the tongue part. And there I have it moved correctly, and as you see, it's capturing my history at the bottom, which is a good thing. So here I just select that and I turn back on the body, and by eye I just extrude it up until it kind of overlaps the body, and you see there 30 millimeters. Luckily we could do this because he did standardized sizes of the bodies, pretty good rounded by 10s usually. So usually it snaps pretty easily. And then here I'm doing the bottom of the tongue. So I just by eye get really close until it looks like that it's close enough to work with, which is somewhere around there. And then I start from there, extruding upwards, and extrude all the way up till it overlaps. I just project the previous image. You see here, go take next structure, and I project it up into the other sketch. Then after I do that, I basically extrude that guy all the way up to where it overlaps, which is again a solid number, 17 millimeters. Make sure it joins, because it accidentally created a second body, which I don't want because it's not 3D printable. And then here I show you guys I need to do the inside of the tongue, the little flange that separates the two 608ZZ bearings, which I have now received in present time. And we see a size of I think it was 3 millimeters, something like that. So I go bring out my notebook and try to figure out what the center of that is, and then go down half of the 3 millimeter thickness. So I should have just done 15 millimeters minus 1.5, and then that is the height that I need to do the plane with. So here I'm showing you guys that it's 30 millimeters, and 30 millimeters, divide that by half is 15, and then subtract the half of the size of the flange. The flange is like 3 millimeters, so half of that is 1.5. And so we need to do a construction plane that is projected off of the base plane, 13 and a half millimeters tall. So give myself a second to calculate that. And I think after this one, I just kind of eyeball it for the most part. I just kind of eyeball it on all the other STLs that I do after this. And so here I need to actually do the inside, which again snaps very easily because it's a standardized size. And then I had the issue of it not joining again, and there we go. So there's basically the correct size of the two put together. Everything's good, but you see that strip there on the back where there's two sections there. That causes a lot of problems. That's why I'm saying that do it differently. And I'm showing you guys what I did there. I did the tongue bracket, which is the second little end on those rods. So it's right there next to the 90-degree offset elbow thing, and so you'll see it there. It's used only once on each of the arms, and here I'm saying I should have probably modeled the fork, because the fork is used more. The fork is used one there. They're used twice on each arm, so there's a total of 6 of them instead of the few that the 3 that I used. I mean, but they all have to be modeled anyways. So not quite sure what I'm talking about now. I'm saying probably what I was saying before is that you could some of these I could print without modifying it and stuff like that. And here I talk about the bearings, which I ordered at the time and I already got. I got about a few days ago. I ordered those from China, slow shipment from China, so it took like 16 days or something. Oh no, those actually I ordered local. I remember now. So there's the fork, and I think I'm actually right now I'm talking about how they're printed or something like that. And there's only about a minute left. And I mean, that's pretty much it for this video. So I'm going to go ahead and start the, go ahead and do my outro. So this is Steven from LegitTechTutorials. I'd like to thank you guys for watching. If you like this video, please subscribe more videos like in this series or series as well. See you guys next video. There's only, I think there's only 2 of these that I messed the audio up with. So the whole series isn't going to be like this. It's only the first, I think it's till number 4 that I had issues with it. So the videos after this will be fine. So you won't have to deal with this again. You could deal with real-time audio. So, yeah, so I'll see you guys in the next video. I'd like to thank you guys for watching. I'll see you guys later. Peace.